Right, hello everybody, back again for another conversation about white-headed vultures. This is the third and final instalment in the session. It won't be as long, this one, and I admit to a delay, which I'm sorry about. The reason being that I recorded this session previously, which is about reversed sexual dimorphism in white-headed vultures, and I watched it back, or began to watch it back actually, and realised that it was so very boring, and I didn't want to inflict that on you, so I decided that even if I was going to sleep during that recording, it wouldn't have been very interesting for you either. So I've decided to take a slightly different approach today. We are still going to be talking about reversed sexual dimorphism in white-headed vultures. That's where the females are bigger than the males. Quite common in birds of prey, not so common in vultures though. But I wanted to see about getting some audience participation here, which is always much more fun. And I was just going to start by saying one of the really fun things about being involved in research, scientific research or any sort of research, is that you get to ask lots of questions, and that's not always in a scientific techie sort of a way. For me, it often starts with that's interesting, I wonder why that would be the case. And so having formulated these questions, we can then set about trying to answer them, and that's where the experiments come in, or that's where the research design comes in, whatever it might be. But that's one of the fun parts about being a scientist, is you get to dream up ideas and then test them and see what works, what doesn't, what makes sense. So today's topic, like I said, is reversed sexual dimorphism in white-headed vultures. But I'm just going to start by reminding us all of some of the characteristics of white-headed vultures. Here we've got the female white-headed vulture with her distinctive white secondaries, and the male down here, which tends to have grey or very pale secondaries compared to the female. So there's plumage dimorphism, which is unusual. In fact, there's no other African vultures that have such distinctive plumage dimorphism as the white-headed vulture. But as we said previously, and this is where I hope you've been taking notes and can refer to them again, the females are also bigger. So weight-wise, the females are around about 15% on average. It varies a lot, of course. About 15% heavier than the males. And then if we think about wing length as well as one of the other metrics that we use regularly for measuring birds, the females have a wing length that's, again, on average, and it varies a lot, between 5 and 10% longer than the males. So she's a bigger bird overall. Beak size actually doesn't seem to vary very much. So the head size and the beak is roughly similar. But weight and wing length, two key metrics for measuring the size of birds. Females are a lot bigger. That's point number one. Point number two, of course, if we remember this picture here, one of my favourite pictures, which is a jacana pair at nest with their juvenile. Here's the male coming in with some more nesting material and the female at nest. And as I said before, they share their duties almost equally at nest in terms of time investment. And then the third point I wanted to talk about, we mentioned about weight and wing length just then. This is the other components that I talked about previously. And if we remember back to the discussion about looking at the size of the talons, the relative size between the different digits on the foot of the bird. So here's D1, which is the big one at the back. Sometimes with eagles we call that the killing talon, because that's the one that they really grip with. That's the biggest one. D2 here, and then D3 is the long one. And what's weird about white-headed vultures is the female's a bigger bird, but she has bigger, this one here, this talon here and this talon here are bigger than the male because she's a bigger bird. That's to be expected. But what's unexpected with white-headed vultures is the fact that the male has a much longer middle talon, D3. So if we look at our talons like this, D1, 2, 3, 4, the males have a significantly longer middle talon. Why would that be? And this is where we get to get your audience participation in as to why these features might exist in white-headed vultures when it doesn't exist in other vultures in particular. It exists a lot in other birds of prey. So reversed sexual dimorphism is quite commonly seen in predatory birds of prey. So eagles, some of the predatory eagles, falcons in particular, hawks especially. And there's no fewer than 20 different theories as to why reversed sexual dimorphism exists in birds of prey. A lot of the time it's assigned to the division of effort at the nest. So the large female needs to sit at the nest on the egg or eggs while the male goes off hunting and providing food. So he needs to be smaller and more agile to hunt more effectively and provide the female who has more mass and can sit at the nest for longer periods while the egg is being incubated. And that seems to work quite well. So a division hypothesis at the nest. Except the problem we've got with white-headed vultures in that theory is, like I said before, they spend almost equal amounts of effort at the nest, sitting on the egg and rearing the chick. So those kinds of hypotheses that discuss difference of effort while you're breeding, they kind of go out the window with white-headed vultures. And lots of other aspects go out the window as well. Why would a vulture that's principally a scavenger have reversed sexual dimorphism? So we've talked about other aspects of white-headed vulture ecology, and I hope you've been taking notes all along, because this is the part where the test comes in. And the way I'm going to frame it today is, having highlighted these key points of the reversed sexual dimorphism, I was wondering whether everybody would, or anybody who'd like to, would like to write in their thoughts as to why reversed sexual dimorphism is present in white-headed vultures. It's a scavenging bird. They've got this distinctive plumage dimorphism. They've got what we call a derived talon morphology, which is significantly different between males and females. Not only different between males and females of white-headed vultures, but different between all of the birds of prey. So white-headed vultures have a unique talon structure compared to other vultures and other birds of prey. So that's unusual too. So if we add all those things together, their feeding ecology, their efforts at the nest, their plumage dimorphism, and their different talon structures, and the fact that a lot of hypotheses to explain reversed sexual dimorphism are related to effort at the nest being different between males and females, we have a conundrum. So I'm going to leave it with you now, and I would look forward to seeing all of your guesses, theories, ideas as to why this exists in white-headed vultures. And it's part of the process of investigating, and that's, like I said earlier, the fun part of being involved in science, is dreaming up these ideas and then setting about collecting data and information to test them. So I'm going to leave that with you as thought for the day, for the weekend. I hope it doesn't keep you awake too long at night wondering about it. And I look forward to seeing your answers, and I would use some of them perhaps to maybe even formulate some theories to investigate, but let's wait and see. Have a good day.